What's up, everybody, and welcome to science class. Oh, trying to do my best Vsauce impression there. Here's the answers. 8.6. I'm going to show you all but the very last question. Because remember, that's the one you have to turn in onto Moodle. Number 9. Let's take a look. First, we're drawing a strobe photo of a car that's accelerating. Honestly, you could go any acceleration you wanted with this one. As long as they get farther apart or closer together, you nailed it. Way to go. Next one, your Corolla. My 1999 silver Toyota Corolla, named Carl. Goes from 0 to rest in about 10 seconds. I actually don't know. I never actually timed it, but it's slow. So accelerate, change in time, velocity over change in time. Goes from 0 to 60, so that's a change in velocity of 60 meters per second. Acceleration is 60 divided by 10, 6 meters per second per second. Make sure you have the correct units. Then, can you run with an acceleration of 1 meter per second for 20 seconds? It's a fun question to think about. The Tokyo Olympics are now officially moved to next year. But you'll see at the Olympic Games, you have the 100-meter dash. The world record holder being Usain Bolt. He can run like 12.5 meters per second, roughly. If you were to keep this acceleration for 20 seconds, at the end of that 20 seconds, you'd be going 20 meters per second. You'd be going faster than the fastest humans ever could have run. Congratulations. You would have been amazing. But, alas, you can't. Not physically possible. Next, let's talk about some graphs. Here's our position time. We're moving away. Constant velocity. So velocity is away, so it's positive. Down here, we are sketching this graph. We are moving towards the origin, so we're getting closer to 0. It's towards the origin, so it's negative, and it's constant. We're moving away and speeding up at a constant rate. So it's not a constant speed. We're speeding up at the same amount every chunk of time. That wording can confuse some people. So don't let it confuse you. Be better than that. Number 7. We are moving towards and slowing down. This one's a fun one. We're moving towards, so we're negative, and we're slowing down, so we're getting closer to 0. Remember, this is 0 velocity. This one is often one that confuses people. And because it's got a positive slope, the acceleration is positive. Let's look at number 8, but don't peek at number 9. Don't peek, oh, don't look. So, here's our velocity graph. We're moving towards the origin and slowing down. Then we kind of come to rest for that brief instant, and then we start moving away and speeding up. Okay, this is kind of like if you've ever done like drills, and you're like run to a line, touch the line, and then sprint and like go back the other way. Like as you're coming towards the line, you're slowing down, you stop, touch the line, and then you sprint away. That's basically what this graph is trying to show. If you notice the acceleration the whole time, one big positive line. It's all going up. So the acceleration is actually one big positive line across. Sometimes people like to put in like this little down to the 0. I don't even worry about that because it's this brief instant you crossing the line, but you're still kind of accelerating the instant you go back the other way. Well, that about does it. Make sure you turn in number 9 onto Moodle because you're great. I know that you're great. If you have any questions, let me know. I will gladly answer anything I can. Have a great and wonderful rest of your day.